Hello everyone. In this video, we're going to be evaluating a rational expression given x squared plus 2x equals 1. So we're given that x squared plus 2x is equal to 1, and we're supposed to evaluate x to the 5th power minus 1 over x to the 5th power. So this problem is pretty interesting, and it is from one of my colleagues on Twitter, Juravich. I hope I said it right. Go ahead and check out his Twitter page. It's full of beautiful problems. So let's go ahead and take a look at this problem. I'll be presenting 2 to 3 methods maybe. Let's see how this goes. So we have x squared plus 2x equals 1. And we're supposed to evaluate based on these x values, x to the 5th minus 1 over x to the 5th. Okay, let's start with the first method, which should be fairly straightforward. We're going to be solving for x. Let's do it. So I want to take advantage of perfect squares or completing the square. Let's add 1 to both sides. You could also use the quadratic formula, same thing. And then we get x plus 1 squared equals 2. There are two numbers in the real world and also in the complex world. There are two numbers whose square equals 2. Those numbers are square root of 2 and the opposite of that. So we can write this as x plus 1 equals plus minus square root of 2. And then subtract 1 from both sides or add negative 1, you're going to get the solutions. The quadratic formula gives you the exactly same thing. So those are the x values. Which one am I going to choose or use? It shouldn't matter, right? So let's go ahead and use the more positive one, the one with the plus sign. So suppose x is equal to negative 1 plus root 2. And then how do you use this? You just plug it in. I do need x to the 5th power. So there's a couple different ways to approach it. You can square x and then square that again and then multiply by x, or you can just directly raise it to the 5th power by using the binomial theorem, which is not too hard. It's just a little time consuming, and you got to be careful to make sure you got it right. But anyways, if x is equal to negative 1 plus root 2, then x to the 5th power, to keep a long story short, should be 29 root 2 minus 41. Obviously, when you get an expression like a root 2 plus minus b, and when you square it or raise it to any power, you're going to get a number of the same form, okay? And those numbers make up an interesting structure in algebra, so on and so forth, but that's a different story. Anyway, so this is x to the 5th power, but I do need x to the 5th minus 1 over x to the 5th. So I also need the reciprocal of this, but that's kind of easy because if you think about it, the reciprocal of a radical expression is going to be the reciprocal basically of the conjugate. So if you multiply, so in other words, this is going to be 1 over 29 root 2 minus 41. And if you multiply the top and the bottom by 29 root 2, 29 root 2 plus 41 divided by 29 root 2 plus 41, you're going to notice that this becomes 1. Because if you square 29 and multiply by 2, it's the same thing as 41 squared. I mean, the difference is 1, sorry. They're not the same. Otherwise, it's going to be 0. Okay. So from here, we get the following. This becomes 1 over 29. Okay, I should write the simplest form, which is this becomes 1. So the answer is 29 root 2 plus 41. So I got x to the 5th power, and I got 1 over x to the 5th power. So all I have to do is find their difference. So what is x to the 5th minus 1 over x to the 5th? And it is 29 root 2 minus 41 minus 29 root 2 plus 41. Of course, you have to expand it and negate everything inside the parentheses. And that gives you minus 29 root 2 minus 41. 29 root 2 cancels out, which is nice because we get rid of the radical. And the answer becomes a negative number, which shouldn't be a surprise because, you know, it's just negative, whatever. Negative 41 minus 41, that should be negative 82 as the answer. Okay, so that's the answer. Let's go ahead and take a look at the second method and maybe at the third method as well. Okay, so the second method. For second method, I'm going to use a really nice approach, and that is taking advantage of expressions like x plus minus 1 over x, x squared plus minus 1 over x squared, and expressions like these. Expressions like these are very much related. So if you can get one of them, you can get to the other ones. Because when you look at x to the fifth minus 1 over x to the fifth, it kind of tells me, okay, if I can get to x minus 1 over x, hopefully I can go to this one. Makes sense? So that's my motivation. How can I find x minus 1 over x? And yes, exactly, I can do it. Subtract 1, and then subtract 2x, and then divide everything by x. And there you go. You got what you needed, and you got it as a numerical value, which is nice. So x minus 1 over x from here is going to be negative 2, which means for the given equation, x minus 1 over x is a constant. So again, going back to the first method, it doesn't matter which x value you used to find x to the fifth minus 1 over x to the fifth, because it would still give you the same thing, because this is a constant. Make sense? Okay. So let's go ahead and see what we can do with this. First of all, I can go ahead and square it. If I square this, I get 4. And if you square a minus b, remember x squared plus 1 over x squared, that's my favorite way to write it, minus 2ab, but 2ab, a and b are reciprocal, so they cancel out, leaving us with something like this. And as a result, we get x squared plus 1 over x squared equals 6. Awesome. Now, I need to get to the fifth power. So I have different options here. I can square this. That's going to give me the fourth power, and then multiply by x minus 1 over x. Hopefully, that'll give me the answer. Or I can do the following. I can just go ahead and evaluate x to the third. So I take this. I know this is equal to negative 2, right? I think so. And then I'm going to go ahead and cube both sides. And for the cube, I'm going to use my favorite identity again. Remember, what was it? A minus b cubed is a cubed minus b cubed minus 3ab multiplied by a minus b. And there's a plus version where everything is a plus sign. Isn't that easy to remember? And this is actually the plus sign version is the basis of the cubic formula. So that's why it's an important identity, and we use that a lot. Anyways, if you expand it, x cubed minus 1 over x cubed minus 3ab, you see ab comes up again, but that's 1. So I just need to multiply by x minus 1 over x, which is a minus b, is equal to negative 8. Now, I do know that x minus 1 over x is equal to negative 2. Remember, that was found from the original equation. So now I can go ahead and plug it in, and this gives me x cubed minus 1 over x cubed, as this is plus 6, but I'm going to subtract it. So that's going to become negative 14. So I got two things that are very important. I got x squared plus 1 over x squared and x cubed minus 1 over x cubed. Now here's the fun part. Experimental. What happens if you multiply these? Well, first of all, when you multiply them, you're definitely going to get x to the fifth. But are you also going to get minus 1 over x to the fifth, and everything else is going to kind of cancel out or simplify? It should, right? Normally. But the cube, the sum of two cubes is negative 14. And if you remember, this was 6. So this is supposed to equal negative 84. But let's go ahead and see what happens inside the parentheses. Let's distribute. We get x to the fifth plus x cubed times 1 over x squared minus 1 over x cubed times x squared minus 1 over x cubed times 1 over x squared is just easy, 1 over x to the fifth power, and that the whole thing is equal to negative 84. Great. Now take a look at this. X squared cancels out with this, and then x squared cancels out with this, leaving us with x to the fifth. I'm going to bring this over, minus 1 over x to the fifth, and then plus x minus 1 over x equals negative 84. Now, you got to remember, x minus 1 over x is equal to negative 2, right? Or was it positive 2? Let's check it out. X minus 1 over x is negative 2. So what I'm supposed to do is add 2 to both sides. If you add 2 to both sides, then you're going to get x to the fifth minus 1 over x to the fifth equals negative 84 plus 2, which is negative 82. And that's the same result as with the first method, right? Of course, they should be the same. You can't get a different answer by using different methods. Hopefully not. Okay. Now, we can briefly talk about the third method. The third method, obviously, and I'm sure you're going to find the fourth method. Please let me know if you do. I'm curious, but here's what I can think of. I can go ahead and kind of isolate x squared from here and write it as 1 minus 2x. And then I can square it. That's going to give me 1 plus 4x squared minus 4x. And then now x squared can be replace with 1 minus 2x. So that's going to give me 1 plus 4 times 1 minus 2x minus 4x. And then you can go ahead and simplify this. So in other words, this is going to give you x to the 4th in linear form. And then you're going to multiply it by x and get the x to the 5th in linear form. Put it together, make a common denominator. You're going to get x squared again. And then plug it in. And then eventually you should find a numerical answer. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.